Unfortunately, what happens here is this, is all the printers that I have access to next to my office, then in the hallway, downstairs, in the basement, all of those that I have access to in the morning, I cannot send stuff to it. It only works as a copier. So I have to print it out somewhere else at home or something like that and bring it up here, which defeats the purpose. So the only place I can have access to is the library.
Yeah.
But they don't open till now.
Yeah.
It's too late. So I'll get it to you next time. Also, you do have access to it already. It's on that sheet I gave you each week when we finish everything, the video and note sheet.
Yeah.
On the column that says examples, that's the stuff I'm giving you. You can go each one of them and click on those, do those, but I will give you a copy of it anyway. All right. So to begin, any questions of chapter 1 and chapter 2? Chapter 1, we dealt with what? Linear equations. Right. And learn intercepts, since we got the basics out of the way. Chapter 2 is what?
Tangent slopes, transformations, increasing, decreasing.
Right. So it has to do now with changing the changes that a function can undergo. Very good. Very good. So the problem is for us, we have to now develop. Up until now, we've always talked about the real number system. What do we mean when we talk about real number system? What was the first type of numbers we talked about? The first type of numbers we talked about were called natural numbers, or commonly called the counting numbers. The counting numbers. When you play a game and somebody asks you to start counting, you start with what? 1, 2, 3. That's what natural numbers are. Okay, then we developed another number at that point. Then we went to what's called the whole numbers. The reason, well, not the reason, but what I say happened, the reason they call it the whole numbers, because these numbers begin with a whole. These numbers begin with 0, 1, 2, 3, and go on forever and ever and ever. Those are the whole numbers. Then we went a little bit further. We weren't happy with that. There's more we can do. What's missing? Well, the negative numbers. We call these integers. Integers go from negative infinity to negative to 0, and then all the way to positive infinity. They're integers, they're the numbers. Was that enough? No. Because what happens between 0 and 1? How many numbers are between 0 and 1? Infinite numbers. We call those rational numbers. Ratio is simply a fraction. Because now between 0 and 1, we have 0.2, 0.3, 0.5, 0.8, and so on and so forth. We have decimals. 3 divided by 5 equals 0.6. So we now have decimals. We have numbers between numbers. There's an infinite number of those. What comes next? So we have the counting numbers. We have 0 counting numbers. We have the negatives and the counting numbers. We have everything between them. What comes next? Is it? Or are they the numbers? Yes, this is where the complex comes in. This is the perfect world. We can calculate stuff. We can get real numbers. We can get answers. Are those all the numbers that there are? No. For example, what happens if I gave you that and I ask you to solve for X? How would you do it? Nope. Because that is just too easy. What if I gave you 3 here? What would you put in there instead? Okay, let's try something even more difficult then. That's too easy. Yeah, because you're solving for X, so you would add 3 to both sides. This is what we spent the first 8 weeks of the semester learning how to do. Not plugging and playing, but solving. So now we have X squared equals 3. So what does X equal now? Yeah, we have to get rid of the square. How do you get rid of the square? You square root it. Whatever you do one side, do the other side. So the square root and the square cancel. But we're still not done. Because that's not what the answer is. That's not the answer. Remember, what is this exponent number called in an equation? What do I always call the exponent? The degree. Whenever you have an equation that has an exponent, the largest exponent is called the degree. What does the degree tell us? The degree tells us the maximum number of solutions possible. It also tells us the shape of the graph. How do I mean the shape of the graph? How does the degree tell us the shape of the graph? Well, let's see. What does that graph look like? It's a parabola. So it looks like this. So we know that this function, since it's x squared, is a parabola. The graph will look like that. If we had x cubed, what's that going to look like? How do you mean S? Yes. It will look like this. What's that? Yeah, that's why I'm gonna hold off on that, because you guys spend too much time trying to look where we are in those papers instead of just listening. So that's how the degree tells us the shape and the direction of the curve and what kind of graph we're gonna have. But, okay, so the first part, how many solutions? So how many solutions is this equation gonna give us? 2. How many do we have here? No. You see 3 here? You see 3 solutions? 1. How do we get 2 from this? Whenever you take a square root of a squared number, you have to put a plus or minus in front of it. Whenever you take a root of an even powered function, you must place a plus and minus in front of the solution. So if the degree is even, and again, in this case it's squared, so I took a square root. What if it was x to the 4th? What would I take? But what here I took a square root of both sides. What would I take? So if I had x to the 4th equals 16, how do I get x by itself? No. If I divide both sides by x, then I have an x here. I haven't solved for x yet. Yeah, whatever this is, that root goes in there. So I take the 4th root of 16. This is called a square root because there's an invisible 2 here. This is called a cube root because it has a 3. This is called a 4th root, and so on and so forth. This is called an nth root. So whatever your exponent is, you have to make sure that the root, this number here is called the root, is the same because they cancel out. So the answer is plus or minus the 4th root of 16. Why do I put plus or minus? Because this root is even. Whenever the exponent is even, your answer is going to be plus or minus. So what is the 4th root of 16? What does it mean? So what this is asking. Fourth root of 16, that's what this is saying, means this. What number times itself 4 times equals 16? That's what it means. Whatever. So when we had square root of 9, what's the root there? Yeah, remember there's an invisible 2 there. So my answer is, what number appears twice? So what is 9 made up of? 3 times 3. I'm looking for a number that repeats itself twice. I'm looking for a square root. There's 2 3s, so the answer is 3. That's how it works. So in this example, if I had the 4th root of 16, what I would do, I'd come over here first. What is 16 made up of?
4.
You can go 4 by 4, or you can go 8 times 2. Does anything that multiplies together equals 16? Keep on going. What's 4 made up of?
2.
What's 4 made up of? So it's made up of 2 times 2 times 2 times 2. Is there 4 of a kind in there? Yes. Since there's 4 of a kind, that's what I need there. The answer is 2. That's how radicals work. That's how radicals work. Now, when I asked you, originally I was going to put this. I asked you to work it out. Not by plugging and playing, but to working it out. What I'm looking for is what 2 numbers multiply together to give me 4. The way I do that is I take the square root of both sides. Because this is squared, I have to put a plus or minus in front of this. So the square root and the square cancel. What's the square root of 4? 2. So the answer is this. X can be positive or negative 2. X can be a positive or negative 2. Let's prove that. So let's back up here. X squared equals 4. Let's say X equals 2. So if we have 2 squared, 2 squared is 2 times 2, that equals 4. Check. What if X equals negative 2? Negative 2 squared is negative 2 times negative 2. Negative times negative is a positive. 2 times 2 is 4. So that's why it's plus or minus. So if your exponent is even of your x, and you take the x root of it, if it's even, you have to put a plus minus in front of it. Does that work with odd exponents? Why not?
Negative and a positive will give you negative number.
Yes. I mean, you're there. You just, let me fill it in for everybody else. You see it perfectly. Thank you. X cubed equals 8. So how do I solve for X? Not square root. I can't use square root. I have to cube root it. I have to cube root both sides. So the root and the exponent cancel, leaving just X. So now, what is 8 made up of?
4 times 2,
2 can't go any further. It's done. What's 4 made up of?
2 times 2,
So 8 is made up of 2 times 2 times 2. Are there 3 of a kind? Yes. So that's the answer. Because if we took this answer and plugged it into our original equation, two times 2 times 2 is equal to 8. Is it a plus or minus 2? No, because if we put X equals -2, then X cubed equals 8 would not work. -2 cubed equals 8. So it's -2 times -2 times -2. Does that equal +8? Negative times negative is a what? Positive times negative is a 2 times 2 times 2 is 8. That doesn't work. So if it's odd, it's either going to be positive or negative. It's one or the other. If it's even, then you have to put a plus or minus. Is everybody aware of what exponents mean? This number up here is called the exponent. What's this number down here called?
base.
The base. Very good. So the exponent tells you the number of times the base is multiplied to itself. That's what the exponent does. Everybody okay with that? So let's see how well you understood this. What's that going to equal?
4.
Anybody agree? No. What's this one going to equal?
That's 4, you're almost -4.
What's the difference? Order of operations. Everything boils down to order of operations. Remember, in order of operations, what comes first? Special operations or multiplication division?
Special operation.
What we have here is we have a negative times 2. This is an exponent. So what this says is negative 2 times 2. This exponent only belongs to that number 2. That's all it belongs to. So the answer is negative 4. This one, since it's in parentheses, this exponent belongs to the whole thing. So we have negative 2 times negative 2, which is negative, negative is positive. 2 times 2 is 4. What's that one going to equal? Exponents are not multiplication of 3 times 2. This negative is on the outside. Here's the parenthesis. So this exponent belongs to the parenthesis. So it's a negative. I have 3 times 3, which is a negative 9. How about that one? Put your phone away. You don't need it. No, away, off your desk. You should not be distracted by your phone at all, ever. What do y'all think?
It's, um,
Okay, we have negative 9, 9. What else y'all think? You got 6, negative 6? If you have not answered yet, please answer. You think it's negative 9. Doesn't negative times negative cancel?
yeah.
The answer is negative 9. Because multiplication, what does this 2 belong to? To the negative 3 inside the parentheses. So this negative stays out there. So we have negative 3 times negative 3. Negative times negative times negative is negative. 3 times 3 is 9. So you have to be very careful about parentheses and what that exponent is touching. The exponent belongs to whatever is right below it. This negative is not part of that too. What do I mean by that? Negative 2 is negative 1 times 2. They're two separate equations. So in this one, that 2 belongs to this parenthesis. What's the parenthesis? Is just a 3. So it's 3 times 3. So be very careful when you start looking at these equations. What's that one going to equal? Remember, this is a math course. You should be writing this stuff down and working it out instead of trying to do it in your head. Don't try to do math in your head. What do you have to do first? By the order of operations. Do inside the parenthesis first. So that's 5 minus 7 is what? Now, since they're opposite signs, take the sign of the bigger number. 7 is bigger than 5. The answer is negative. 7 minus 5 is 2. This negative stays out in front. This negative 2 is raised to the power 3. So it's negative 2 times negative 2 times negative 2. How many negatives do we have? So what does that make the answer? Positive or negative? Yeah, negative times positive, negative times negative is positive. Positive times negative is negative. Negative, negative is a positive. So the answer is going to be positive. 2 times 2 times 2 is 8. Again, always follow the order of operations. Do things step by step. Don't try to quickly do it in your head. That's where the mistakes happen. Since we're talking about exponents, might as well jump into the whole topic of exponents first, because that's what we'll be dealing with from here on out. The properties of exponents. X to the power. So what's the exponent in that example? N. What does N represent? Any number. Any number from negative infinity to positive infinity. Does it have to be a number? No. It could be an equation. It could be a symbol, like pi, or cosine of X. It could be anything. First rule. If the bases are the same and you're multiplying two numbers together, if the bases are the same, then add the exponents. For example, we had 3 squared times 3 to the third. What's that going to equal? Since the bases are the same, I add the exponents. I get 3 to the fifth. Like I always ask, I ask the question, why? Why is it 3 to the fifth? Well, let's see. Because this first number is 3 times 3 times the second number, which is 3 times 3 times 3. They're all the same number. They're all threes. How many times do they occur? 5 times. Then we can't use this formula. We'll get to that later on. Good question, though, but that's out of the scope of this discussion. If it's not the same basis, we can't use these rules. These are only if the bases are the same. if you have an exponential number raised to a power, so a power to a power, right, the base alone, and then multiply the exponents. So if we had 3 squared to the power 3, what that equals is multiply the exponents, 2 times 3, which is 3 to the 6. Why is that? This parenthesis is raised to the power 3, so it's 3 squared times 3 squared times 3 squared. 3 squared means 3 times 3 times another one, 3 times 3 times another one, 3 times 3. They're all threes, and we have 6 of them. So that's why that's how it works. Remember, the first day of school, we talked about all sorts of properties. The associative, the distributive, the commutative, all these other properties. These all apply here. They'll always, always, always apply. Whenever you have a product, numbers that are multiplied together, or letters to number 5x, raised to a power, what that means is everything this exponent distributes to everybody inside there. So if I give you 5x and it's cubed, what would you do there? Yeah. This 3 distributes to every term inside there. So we have 5 to the power 3, x to the power 3, and whatever 5. So 5 times 5 times 5 is 125. This is 5 times 5 times 5 times x to the third. So why is that? Because this exponent says I have 5x times 5x times 5x. What that means, I have 5 times x times 5 times x times 5 times x. Can I move those numbers around? If so, why? How? What tells me I can move those numbers around? It's the first week of class. I asked you all, I went through all the properties, I asked you all to memorize them, which you'll need to do all this stuff. So what property tells me I can move these numbers around? No, that's not the property. I asked you for a property. Because you cannot do anything in math unless there's a rule that says you can do it. Four of y'all are looking at your notes. Very good. The rest of y'all are staring at the board thinking that some deity is going to jump out of the board and give you the answer. No, that's not how it works. Of what? Very good. The commutative property of multiplication. They're all multiplied, so it's multiplication. Commutative means I can move. So I can rearrange these numbers because they're all multiplied. I could move all the fives together, and I can move all the x's together. 5 times 5 times 5 means 5 cubed. Times x times x times x is x cubed. That's how the property works. Again, the more you memorize the properties as we go along, the easier math will be for you. It also works with fractions. Just whatever the exponent is, it distributes to both all the numbers on top and all the numbers on the bottom. So how would I expand this one? Three to the fourth, x to the fourth, 5 to the fourth. Everything inside there gets the exponent. It's distributed. Because remember, I never told you what x and y were. X and y are variables. They could be numbers, they could be letters, they could be equations, they could be whatever. But that's how it works. Whatever's inside there, if it's all multiplication division, I can distribute in there. Note. What would this one be?
Plus 2x plus 2 is x squared plus 1.
Can we distribute like the other ones?
No, because they're separated, their terms,
How do you mean in terms?
because they're separated by a plus.
Right. Because the plus or minus sign makes it an equation, not a value. Because x times y is a value. Very good. Y divided by x divided by y is a value, not an equation. X plus 2 is an equation. What this would give us would be x plus 2 times x plus 2, which means we'd have to multiply them out. X times x gives me x squared. X times 2 gives me 2x. 2 times x is 2x. 2 times 2 is 4, which would give me x squared. 2x plus 2x is 4x. And we'll cover that later on, so don't worry about that. We'll cover that later. I can't stress enough, just because you're writing this stuff down doesn't do you any good unless you review it, you study it, you learn it. Let's see here. What if I have a question like this, an equation like this? What this one tells us, since the same base is top and bottom, I subtract the exponents. Why would I subtract them? Remember earlier when we had the same bases and we multiplied them, when we had the same bases, we added them. Why is it now when we have the same bases and we divide them, we subtract? It has to do with multiplying and dividing. When you multiply things, do you make them bigger or smaller? Bigger, so you're adding them, making it bigger. When you divide them, you're making them smaller, so that's why you subtract them. So if I had x to the fifth power over x to the third, take the powers, 5 minus 3 is x squared. Notice, it's the top number first and the bottom number second. The reason for this is x to the fifth over x to the third. X to the fifth means x times x times x times x. X to the third means it's 3 times. By the rule of division, if you have the same numbers on top and bottom, what can you do with them? We can cancel them. So that x cancels, that x cancels, that x cancels. So all we have left is x times x, which is x squared. That's where it came from. Because we're canceling, we're removing, that's why we subtract. How about this one? If we use the shortcut method, what do we get? Yes. But in the convention of mathematics, you never want to have a negative exponent as an answer. What this tells us, whenever you have a negative exponent, what that means is to get rid of the negative exponent, we have to change the position of where that number is with respect to the dividing line. Remember, this is all over 1, right? So since that's negative, it has to go to the bottom, and I drop the negative. So it's 1 over x squared. So that brings us to our next property. A negative exponent simply means you change the location of it with respect to the dividing line and drop the negative. X to the fourth over x to the sixth. X times x times x times x. 3, 4, 5, 6. So we reduce 1, 2, 3, cancel 4 of them. So what are we left with on top? We're left with a 1. Even though everything cancels, it's still always a 1 up there. It's a fraction. These two are on the bottom. The most common mistake students do is whenever everything cancels, I think there's nothing there, so I don't have to worry about it anymore. It's just x squared now. No. X squared, there's 2 x's on the bottom. There has to be something on top. There's always a 1. Because what happens, how many times does x go into x? 1 time. How many times does x go into x? 1 time. X goes into x 1 time, x to x 1 time. 1 times 1 times 1 times 1 is 1. These are all multiplied together. How would you do that one?
Same logic as the other one, right? You just move the location. So X to the power of -5 gets moved down. to the denominator.
Okay, so there's an X to the third on the bottom. So this one goes down to the bottom. And then what? Look at the first, these are same bases and they're multiplied. What do you do with the same bases and you multiply? Add the exponents. Is that the only way you could have done it? No. As long as you follow the rules of math, you can do anyhow you want to, and it's always going to give you the same answer. So we have the same equation. This time, the 3 and the 4, let's stay there. Whenever you have x's on top and bottom, what do you do with the exponents? You subtract them. So you have -5 on top minus whatever's on the bottom is a 3. -5 minus 3 is -8. Since that's negative, the whole thing moves down. As long as you use the rules, you can never have a wrong answer. As long as you use the rules correctly, you'll never have a wrong answer. It's just that if you're not sure what to do, you just guess, you make up something, that's where the wrong answers come in. Notice they're both the same answers, but we did it different ways. Is one way wrong? One way, no, they're both correct because we use the rules. X squared means what?
Base multiplied to itself twice.
It's X times X. So what is X? How can we write X? How is this true? How is this true? Do we have any rules to prove it? Well, yes, we do. The first rule, let's look at this side. What is X times X? What's the power of X? How many times is the exponent? This one says there's 2 X's. This one says there's how many X? There's only 1 X. This is 1 X. So what this tells us, using the rule, same basis, what do you do with the exponents? That's why this is true, because X by itself is the same thing as X to the first. You have to have a rule that says, that proves what you're doing. So the reason X squared is X times X, because X is the same thing as X to the first, because of this. X to the 0 is what? No. No.
One.
Why?
Any number divided by itself is just 1.
That just says that's the X to the 0. How'd you get? I know you're looking at the notes we talked about earlier, but why? Yeah, you can't just read what I gave you earlier. You have to understand what I gave you earlier. There's more to it than that. You gave me the proof, but you're using it wrong. It's great that you're using what I taught you, but you have to make sure you use it correctly. Why is x to the 0 1? Theoretically, you're correct. Because if x to the first means there's one x, x to the 0 means there's what? No x's. Every number has what in front of it? Yeah, so x to the 0 is the same thing as 1 times x to the 0. So looking at the way you answered it, yes, that means that there's no x's, which means it's just 1, because there's no x's. Yes, but that's more of a philosophical proof instead of a mathematical proof. But what the proof is this: you have to use what we discussed so far. You have to use the rules we discussed so far to prove this. Only thing we can prove right now is what 1 equals. What equals 1 all the time? 1, that's true, but what else? Just x? Can x be anything else other than 1? Yeah, x is a variable. It could be 2 or 3 or -1. But if we take x over x, I don't care what x is. X can be horse. Horse over horse is 1. Since that's always true, any number we give it, any exponent we give it, it's also true. Now applying our properties, since I have the same bases, I subtract the exponents. N minus n is 0. I want this to be in your heads, not on your papers. Everybody okay so far? Now, let's go back to what we talked about earlier. We took a side trip through the forest and smelled some roses and looked at some birds.
But does that only apply for x or just any number to the power of 0 is 1?
Any number.
Does that include 0 too?
Ooh, no, no. Because 0 by itself is what? 0. There's nothing. So even if there's a 1 in front. So if you have nothing and you took a 0 of that, then there's also nothing.
Okay.
Very good question. So that's a more philosophical question now. Very good. Which goes in the same questions of, if that's the case, then 0 over 0 should be 1. But 0 over 0 should be undefined. 0 over 0 should be 0. That's why 0 has its own set of rules. Ooh, you made me know my thought. Okay. So now, as we started off with this type of equation. Now, if I give you an equation like this, don't try to solve it by plug and play. Solve it mathematically. What are the steps to solve this? First step is what?
Isolate the 0.
Yes, isolate the variable you're solving for. So we add 4 to both sides. Now we have to get rid of, to get the x, we're solving for x. We have to get rid of the square. How do we get rid of the square? We have to square root it because it's base 2. I mean, the exponent of 2. So I have to do that the same thing to the other side. But because I took a square root of an even exponent, I have to put a plus or minus in front of it. So x is equal plus or minus 2. And we can always check it. Positive 2 times positive 2 is 4, negative 2 is 4. So all the planets are happy and lined and everything. Let's look at this one. Okay. So x squared equals negative 9. Then we square root both sides. Very good, very good. What are we missing? Yeah, we're missing a plus or minus. Because anytime you square root of an even exponent, you have to put a plus minus in front of it. So the square and the x squared cancel. So we have x equals plus or minus, what's the square root of negative 9? No, because 3 times 3 does not equal negative 9. Is it negative 3? No, because negative 3 times negative 3 is positive 9. Now we have a problem. Houston, we have a problem. This is where imaginary numbers come in. Imaginary numbers are called that is because we can't really graph them. So we say here, there's no real solution. We can't say there's no solution anymore because there is a solution. It's just not real. So let's see what it is. There's a concept. The square root of negative 1. Because we know the square root of 1 is 1. But because there's a negative inside the square root, it doesn't exist. We call it I. I stands for imaginary. So when we had square root of negative 9, I'll show you how it came from, and then we'll just jump straight to the shortcuts. So square root of negative 9 is the same thing as square root of negative 1 times 9. There's a property of radicals. These are called radicals. That square root symbol that says if I have the square root and I'm multiplying things together, I can split them up. Or conversely, if I have them separated, I could combine them. So what this thing tells me is since these are multiplied, I can split them up because of this. So what is the square root of negative 1? Square root of negative 1 is I. What's the square root of 9? So the answer is 3i. The square root of -9 is 3i. So here are your formulas. We know I equals square root of -1. This is the same thing. If I square both sides, what do I get? If I square both sides, what do I get? What's the square root of -1 squared? Because the square and the square root cancel out. There's the square root of 5 and I square it is just 5. Because the square root and the square cancel. So these are the symbols we'll use for this whole section from mathematics from here on out. Whenever you have an I squared, you put a -1 inside in the answer. Whenever you have an I, that's the same thing as square root of -1, or whenever we have a square root of -1. Let's look at some examples here. Because there's a rule in mathematics. You cannot have an answer with a negative square root. So what's that one going to equal? What's that? Nope. How do we do the last one? Well, this is the same thing as -1 times 7. True? So now I can split those up. Square root of -1, square root of 7. What is the square root of -1? I. What's the square root of 7? Square root of 7. So there's your answer. I square root of 7. Can you guess why we don't put the I after the square root of 7? Are they the same thing? No. This one, the I is incorporated inside the square root. This one, the I is outside the square root. But to remove that possibility, that's why I put the I in front of the square root. Whenever you have an imaginary number and you have a radical, put it in front of the radical. So you don't get mixed up like that. Okay, that was number 1. Number 2, square root of -16. What do y'all think? Very good. Because we have the square root of -1 times 16, square root of -1, square root of 16. Square root of -1 is I, square root of 16 is 4, so we have 4i. That's the mathematical way. Now the shortcut way. Whenever you have a negative inside a square root, take it out, put an I in front. If there's a negative inside the square root, put an I in front and you could drop the negative sign. So now we have I times 4, which is 4I. So you don't have to go through this whole process anymore. Whenever there's a negative inside the square root, just drop it and put an I out in front. So what's that one going to be? Can you do anything with this negative out in front? No, it's out in front, so it stays there. We have a negative inside the square root. What do we do with that? Put an I in front. So what we have left is the square root of 13, and there's your answer. We can't go any further. You have negative, yeah. It's the same as a number. Negative radical negative 64. Very good. Some of y'all get much faster. Some of y'all take forever writing it down. So what's the answer? Negative 8I. The negative stays out in front. The negative inside there becomes an I. What's the square root of 64? 8. So it's negative 8I. Remember, I is like a variable. So if it was X, you wouldn't put X8, you put 8X. So treat it the same way. Negative 48. Right. What's the answer? So what do we do with this negative inside there? It becomes an I. 7 times 7 is 49. So that's not it. So what we do is take 48 and break it down to its smallest pieces. Because how many of a kind do we need? We need 2 of a kind. Because it's a square root. 48 is made up of what?
12 times 4.
Okay, 12 times 4. 12 is made up of?
6 times 2.
6 is made up of?
3 times 2.
4 is made up of?
3 times 2.
So 48 is made up of 2 times 2 times 2 times 2 times 3. We need 2 of a kind. So here's a 2. That's 2 of a kind. This is 2 of a kind. So it's 2 times 2. I. And what's left inside there is the 3. So it's 4I radical 3. There's the answer. Any questions so far? Yes.
So there, so radically, you have 2 times 2, 2 times 2.
You know, there's one pair, it comes out. There's another pair, it comes out.
So every pair you just pull out.
But yeah. Yeah. In the long run. But if we did this, we could have gone 48 is the same thing as 4 times 12. 12 is the same thing as 4 times 3. Here we have a pair of 4s. So that could have come out. We have 3 inside there. All we need is 2 of a kind inside there. Once you see 2 of a kind, take it out. Everybody okay with this? Kind of okay? I don't see too confident there.
Well, how would you write things for that's how we-
This one? This one?
Yeah, how would you
Well, because if we would have done that, then we would have had I is 4 times 4 times 3. If we would have done this one, here's 2 of a kind, so that comes out in front. And what stays, so 3 stays inside there. Now, what we've labored to do is define the title of this section. A complex number. We haven't really defined what a complex number really was. A complex number has this form. A complex number has this form, where A is the real number and BI, is the imaginary number. Or A and B could be any real number. Remember, by any real numbers, I mean anything from negative infinity to positive infinity. Is that a complex number? Yes. Is square root of 7 between negative infinity and positive infinity? Yes. Is 2 between negative? Yes. So this is a complex number. Is that a complex number? Yeah, let's put 8 here. Pi plus e to the 8th I. Is that a complex number? It is. Is pi between negative infinity and positive infinity? Yes, it's 3.14 something. Is e between negative infinity? Yes, it's 2.7181. We talked about e's. It's some value. So that's an example. Is that a complex number? Yes, it is. A is 2 and B is 0. Are those inside the complex numbers? Yes. It's a complex number is any number that can be written in that form. So that is a complex. Is negative 3i a complex number? Yeah, because A is 0, B is negative 3. So yes. So every number you can think of can be written as a complex number. Not really.
You're saying that you're always like thinking of that equation. 8 plus b9.
Yep. If it can be written in this form, it's a complex number.
You said 2 plus 0.
Mhm. This is 2 plus 0i. This is 0 minus 3i. So far, so good. Algebra of complex numbers. Remember, when I say algebra of complex numbers, what do I mean? What does the term algebra really mean in this case? It means I could do add, subtract, multiply, divide to it. Yeah, turn it into an equation. There's a equal something. So let's first off look at add, subtract of complex numbers. Let's look at this one. Well, we solved this one. Is this an equation or an expression? It's an expression because there's no equal sign. So all we can do here is combine like terms. So look at it. Can we do anything inside the parentheses? Can we add 8 and 6? No, they're not like terms. This is 8 and this is 6i. It's a real number, remember? Complex number. One's imaginary, one's real. So we can't combine them. So do we need the parenthesis around this one? Is there a number in front of it? No. So we can drop the parenthesis. How about the second one? We can't do anything inside there. Can we just drop it? Yeah, because there's a positive 1 in front of it. There's nothing to distribute. So we can just say plus 3 plus 2i. I'll give you one in a second where it does change. Now, since the parentheses are gone, combine like terms. 8 plus 3 is 11. Positive 6i, positive 2i is a positive 6 plus 2 is 8i. And there's your answer. How about this one? Well, we can't do anything inside the parentheses. Check. So can we just drop the parentheses? No, it's got a coefficient. So what do we do with the coefficient? Distribute, yes. So negative 2 times 3 is negative 6. Negative times negative is a positive. 2 times 5 is 10i. Positive times positive is a positive. 3 times 4 is 12. Positive times positive is positive. 3 times 2 is 6i. Again, always following the same steps we did from day one. Combine like terms. Negative 6, positive 12. Opposite signs, so we take the sign of the larger, it's positive, and subtract them. 12 minus 6 is 6. That goes those two. Positive 10i, positive 6, they're both positive. 10 plus 6 is 16i, and there's your answer. How about this one? Do we need the first parentheses? No, there's nothing in front of it, so it's just 4 plus 5i. How about the second parentheses? Yes, we do, because there's a negative in front of it. So this negative has to get distributed in there. So negative times positive is negative 6. Negative times negative is positive 3i. Now, whenever you have a negative in front, that changes all the signs inside there. Now we combine like terms. Positive 4, negative 6. 6 is bigger, so the answer is negative. 6 minus 4 is 2. Positive 5i, positive 3i. They're both positive. 5 plus 3 is 8i, and there's the answer. Again, always go back down to the basics. The very, very introductory stuff we did at the beginning of the semester. So that's adding and subtracting complex numbers. Multiplying complex numbers. Remember, x times y is the same thing as square root of x times square root of y. But you have to be careful when it comes to imaginary numbers. This only for real numbers. Because the most common mistake students will do, what would you do here first? Right, looking at this, you'd combine them, right? You'd put -2 times -5. That would give you negative, negative, makes it positive, that'd be square root of 10, right? No. Which is the mistake. That's why this doesn't work in math.
You use I first.
You have to first make them into, yes. So first get rid of the negative inside there. So it's I square root of 2 times I square root of 5. I times I is what? I squared. Then you have negative radical 2 radical 5. I squared 2 times 5. I squared radical 10. Are we done? No. Why not? In radicals, two things. You cannot have imaginary numbers inside the radical in the final answer. You can't have that. And two, you cannot have exponents. You cannot have a radical on the bottom, I should say. You cannot have an exponent on a radical, on imaginary. What does I square equal? Besides us talking about it in the very first part of this section, you guys forgot about it already. Work it out. What does I equal? Square root of -1. If I was to square I, then I square the other side. What happens when I square root the square? They cancel out. So it equals -1. So whenever you have I squared, it simply becomes a -1. So that's your answer.
Does that work with like any other type of exponent, so if it's a.
And we'll get, if we had I to the 56, same thing. But we have to go through that first. It's a whole process. Okay, how about this one? This is the examples. Square root of -16 times the square root of -25. What's my first step? So it's I radical 16, I radical 25. Then what? Gives me what?
So it is I squared,
I squared,
I squared. Square root,
square root of 16 times square root of 25. What is the square root of 16? Square root of 16 is 4. Square root of 25 is, so what is I squared? -1. What is 4 times 5? -1 times 20 is -20. That's how you work it out, step by step. You're right. Take out the negatives first. Simplify each of the radicals as far as you can go. And then start combining it all. One plus 2i times 1 plus 3i. So how are you going to solve this one? Or not solve, but simplify. Yeah, just multiply them together. 1 times 1 is 1. Positive times positive is positive. 1 times 3i is 3i. Positive times positive is positive. 2i times 1 is 2i. Positive times positive is positive. 2i times 3i is what? 6i what? Squared. I times I is I squared. Next step. Whenever you get rid of parentheses, your next step should always be to combine like terms. So what can we combine here?
3i, 2i.
Which gives us positive 5i. Remember, we cannot have exponents on the i's. What does I square equal? So it's 6 times -1. Which makes it 1 plus 5i. Positive times negative is -6. 1 minus 6 is -5 plus 5i. And there's my answer. There's a shortcut we could have done here. Right here. When we had plus 6i squared, whenever you have an I squared, get rid of that and change the sign to whatever the coefficient is. If you think about it, that's exactly what happened in those 3 steps. It went from positive 6i squared to -6. So whenever you see an I squared, just get rid of it and just change the sign in front of it. Simplify that one. So what this is asking us to do is to find 3 minus 7i times 3 minus 7i. 3 times 3 is 9. Next one, positive times negative is positive. 3 times 7, 21i. Negative times positive is negative. 7 times 3 is 21i. Negative times negative is positive. 7 times 7 is 49. I times I is I squared. First step, get rid of the parentheses. Foiling in this case, distributivity.
Oh, no. You get 21i from 3 times negative 7i.
There should both be negative 21i. We have positive times negative is negative 21i. Good catch. Combine like terms. We have 9, negative, negative, both negatives. 21, 21 makes it 42. I plus 49i squared. I squared changes the sign of that 49 from positive to negative. Because I squared is -1. Positive 9, negative 49. So its answer is going to be negative. 49 minus 9 is 40. Minus 42i. And there's your answer. What do y'all think? Explain it again? What part? How do I go from here to here? Well, the square means this whole parenthesis is multiplied to itself twice. Now, what that means is everything in the first parenthesis multiplies everything in the second parenthesis. So the 3 times 3 is 9. Positive times negative is negative. 3 times 7 is 21. I. So that one's finished. Now this one. Negative times positive is negative. 7 times 3 is 21. I. Negative times negative is 49. 7 times 7 is 49. I times I. It's the stuff we've been doing all along. And then combine like terms. Negative 21, negative 21. They're both negative. So I add the two numbers. 21 plus 21 is 42. And then bring this one down. Because it's I squared, I changed the sign in front of that one. I mean, if you don't understand, don't bob your head saying, yes, you got it. Because this is the time where if you understand, it's the perfect time to ask. Instead of trying to do it yourself and not knowing what you're doing. I'm asking you, are you following us? Are you following me or not? Okay. We have a couple more things. We have division to do. That's even more complex because now we have to look at something called conjugates. But before we do that, we have another topic. I to the power n. If I gave you I to the 47th power, what would it be? Remember, your answer if it has I, cannot have an exponent. So we have to break it down this one, so it's either gonna be a 1 or an I. Let's show you how to do that. I is itself, I is I. What's I squared? -1. What's I cubed? Well, I cubed is I times I squared. We just talked about the rules of exponents. So we have I squared is -1. So this gives us -I. This is called building it, proving it inductively, using inductive logic. What is I to the 4th? Well, I to the 4th, start off with I times I cubed. What is I cubed? Well, I cubed is -I. We have positive and negative. I times I is I squared. What is I squared? -1. So that equals +1. So I to the 4th is the same thing as +1. Let's keep on going. I to the 5th is I times I to the 4th. We know I is I. I to the 4th we know is 1. So I times 1 is just I. I to the 6th is I times I to the 5th. Everybody see what I'm doing here? I'm building up from one of the ones I just proved. I'm using that to prove the next one. I use this to prove this one. That's why it's called inductive proof. What is I to the 5th? I to the 5th is the same thing as I. That's what we just proved there. So I times I is I squared. Well, we know I squared is the same thing as -1. I to the 7th is I times I to the 6th. So it's I to the 6th is -1. So it's -I. One more. I to the 8th is I times I to the 7th. I is I. I to the 7th is -I. That gives us -I squared. I squared is -1, so that gives us 1. Everybody follow what I just did? If I keep on going, would you be able to follow me? So let's look what these gave us. We have I squared, I cubed, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th. So from our list, what does I squared equal? -1. What does I cubed equal?
-1,
What does I to the 4th equal?
1,
Then we go up here. I to the 5th is I. I to the 6th is -1. I to the 7th is -I. And I to the 8th is 1. If we look at it carefully, we notice a pattern. They go in groups of 4. Starts with I, goes to -1, -I, and 1. So the next set would follow the same pattern. I, -1, -I, 1. Everybody follow that so far? So every exponent that has I has to follow one of these four numbers. It's easy to remember. Since it follows in groups of four, what pattern is it following? Think about if you ran a race and you won, what would you yell? Besides, I can't believe I finished. I won, I won. I won, I won, and the middle two are negative. So that's the pattern we're looking at. I won, I won. So what does that mean? I won, I won. The middle two are negative. Now they go in groups of four. So in other words, if I gave you I to the 26, we cannot have an exponent, so how do we fix that? The way we do it, we take that exponent, divide it by 4. Because every 4 of these end in a 1. So how many times does 4 go into 26? 6 times 4 is 24. Subtract those, we get 2. This is what we're looking for, the remainder. If the remainder is 1, 2, 3, or 0. There's if there is no remainder. If the remainder is 1, it becomes I. If the remainder is 2, it's -1. If the remainder is 3, it's -I. If there isn't 1, then it's 1. So I to the 26, since the remainder is 2, is the same thing as -1. I know. So it all follows this pattern right here. All right, so let's look at some examples. I'll put those in there. So here's the remainders. And the solution. So the remainder is 1, 2, 3, 0. I won, and the middle two are negative. So if I give you I to the 37, what would you give me? What would that equal? So remember, the first thing you gotta do is figure out how many times does 4 go into 37? This is the hardest part, since a lot of y'all are used to using calculators to do the work. So how many times does 4 go into 37? 9 times 4 is 36. So the remainder is 1. If the remainder is 1, the answer is I. So that's the answer for that one. Next one, I to the 80th power. And you get with any remainder?
No.
Very good. Yeah, because 4 goes into 80 20 times. We get 0 as a remainder, so the answer is 1. Very good. Since the remainder is 0. I to the 58th. Now, this would be perfect time for you to start practicing your basic math skills. Don't use a calculator. Use your calculator to check your answer instead of doing the work for you. So 4 goes into 5 how many times? 1 time. So 1 times 4 is 4. Subtract them. You get 5 minus 4 is 1. Bring down the 8. How many times does 4 go into 18? Yeah, 4 times 4 is 16. Subtract those, you get 2. There's your remainder. Since the remainder is 2, the answer is, since the remainder is 2, the answer is -1. Since the remainder is 2. Then I to the 75th. So whatever the exponent is, divide it by 4. Four goes into 7 1 time. 1 times 4 is 4. Subtract them, you get 35. 4 goes into 35 how many times? 8 times 4? 32. So the remainder is 3. Since the remainder is 3, the answer is -I. Make sense? So your answers can never have a exponent on your I. So there's 2 basic rules here. You can never have an exponent on the I, and you can never have an I on the bottom, which is what we'll do next time. We'll do divisions next time. And then, once we do that, then we start looking at quadratic equations. We start learning how to solve quadratic equations, because we're going to start building from there. Cubic equations, 8th order, 12th order, 75th order equations. And that's what chapter 4 is all about. Of what? Quadratic because it has a square. That's what we're going to cover in chapter 3 mostly. Chapter 4, it could be any exponent. And then we'll talk about what we look for, how we'll graph them, what we need. And then this is where we start building stuff up. All right, everybody, that's it for today. Sorry it took me so long to finish.